Hi, good morning, and thank you for joining us on the webinar today. My name is Phil James, and I'm the Availability and Industrial Computers Product Manager here at Solutions PT. What we're going to discuss this morning is how to increase security by leveraging virtualization and centralization technologies. So if we just take a look at the agenda, what we're going to do is maybe talk through some of the concepts of building secure architectures and the technologies that you can leverage in terms of virtualization and centralization. And we'll also include some product stuff that ties in nicely with that helps you achieve your business goals. So we'll jump straight in. Here we've got the cybersecurity maturity model, which is the ARC model that's used. It really allows us to apply a staged approach to cybersecurity. So I'm sure that you guys are all on that journey at the moment, and will fit in one of these stages on the diagram that you can see there. So really what it's trying to explain or convey is that there's multiple stages, and if you start on the left-hand side, they're typically low cost, easy to implement actions. Moving to the far right-hand side, which is very high cost. So what we'd recommend is that maybe it's worth weighing up the cost versus reward of each step. So it's probably not, or it probably doesn't make sense to jump right in at that far right-hand side if you haven't already prepared the groundwork first of the earlier stages at the left-hand side. So very much recommend that you start small, prepare that groundwork, and then expand and build on that as time goes by. So if we look at building secure architectures, here we've got the past on the left-hand side, so what people have typically done in the past, moving to the present day and how we see the lay of the land now, moving to the future and how we expect this to look in the coming years. So if we start with the past, I guess this is what we call an air gap system. So the SCADA and manufacturing zone are completely segregated from anything else. So that's fine. I guess the physical boundaries or the physical constraints of having these air gap systems suits many people still today. But what it means is that because everything is segregated, you've got no opportunity really to connect your SCADA system to anything else. So that could be things like MES integration, those kind of things. And from a security perspective, you've still got the possibility, that an operator could collect a USB stick out of a car park or something and infiltrate the network that way. Then if we move to the present, which is a much more structured architecture, so you can see there that we've introduced firewalls, and more importantly, there's a DMZ in the middle there. So that's going to act as a gap to bridge secure connection really between the control system and the MES or enterprise layer. So it's a very prudent approach to take, and it could be that you've got a reporting server or something within that DMZ, and by structuring your architecture in this way, and especially if you were to use a layer 3 device where those firewalls sit, it'd allow you to implement zones and conduits. So it could be, if we take that reporting server scenario again, it could be that you introduce a conduit whereby you will allow traffic from the DMZ to the SCADA and manufacturing zone, but only allow HTTPS traffic. So that means that you're going to be able to communicate with that reporting server, but nothing else. So a much more secure way than an air-gapped system, because you've got that flexibility to communicate with multiple layers. So then if we look to the future, that's where everything's connected. So we can see there that we've got supply chain, hardware and software vendors, and then you've got your DMZ and the enterprise and SCADA zones in the middle of the diagram there. So because everything is connected, that obviously brings risk with it. But if we are aware of those risks, then it means that we can utilize people, process and technology to make sure that we're as secure as we can be. So what I mean by that is by people changing people's behaviours, implementing structured processes to make you as inherently secure as possible, and then leveraging certain pieces of technology to make you more secure. So this is a real-time connected architecture of the whole supply chain. So that gives us the utmost availability and flexibility. And then it allows us to take advantage of things like cloud technology and hybrid models. So if you look at some of the technology that you could use for this, virtualization sort of screams out to me. So again, we'll look at this in a past, present, and future perspective. So if we look at the past, this would be where you've got individual physical machines. So there's no virtualization there at all, really. So isolated physical hosts, they're still running in industrial control systems in that instance. Each machine that you have there would need to be patched and managed individually, which obviously brings its own challenges, and that's potentially really difficult on legacy operating systems. So, we still hear of people that have got standalone XP machines, where there's obviously security threats that we've all heard in the news in recent times. So you probably could make use of images and image directly onto those individual physical hosts or those physical machines, but when you use images in that way, it's very important to use the exact same piece of hardware between each image, to prevent the old blue screen. So when we're talking about legacy installations, it can be difficult to source, the old pieces of hardware that can run XP, Windows 2000, that kind of stuff. So then if we move to the present, so this is where we start to introduce private virtualization. So this is sort of centralized control, and that's key to providing a flexible solution. So as you start to use virtualization, it allows us to reduce the surface area of attack. So what we mean by that is you need less or fewer physical instances of those machines, because obviously you can utilize a single physical host in many cases, and then implement virtual instances of your individual machines onto that physical host. By doing that, it becomes obviously easier to manage because you've got fewer physical assets. It then allows us to take advantage of easier incident recovery plans too. And once you go on this path, then it allows for scalability. So you could go from a single line and then expand that to a full site or even a full enterprise if you want to start leveraging cluster technology. And then if we look to the future of what we can do with virtualization, that then brings other technologies and other concepts into the fore, really. So we've got cloud to edge and local fault tolerance and high availability, and then SLA-backed cloud services. So from what we've seen, what we'd probably suggest is for the future it's probably prudent not to move everything to the cloud, and probably keep your control systems as local as you can. But when there's a benefit to introduce cloud systems, then obviously it's worth investigating. So things like Wonderware Online, a cloud-hosted historian fits in nicely with that. So virtualization, it doesn't mean that you've got security in the bag as soon as you implement it, but by leveraging this technology, it allows you to reduce your efforts and manage and secure your architectures more effectively. So here we've got a couple of architectures. So again, we've got a before on the left and an after on the right-hand side. So the before is you've got those physical individual instances on the left-hand side, each with its own operating system and application, in this case a SCADA and a historian. So we've got 3 machines there, and then they're all distributed to a number of thick clients, so another PC with an operating system and an application on there. On the right-hand side, what we've done is we've virtualized those, and they're actually running on a Stratus server, which I'll come on to later on. So that gives us extra uptime, so 99.999% availability, or 5 nines, which I'm sure you've all heard of before. And the virtualization's being done via thin clients and mobile devices on the right-hand side. So instead of those physical devices, you're now not constrained by leveraging other products and technology. You can start to introduce mobility into the mix. So now that there's only one physical server that needs to be managed, and what's more, it's performing a recovery of any of those virtual machines has been greatly simplified. So if we just move on to the FT server, what we've got there is, as you can see by the image, it's two servers really, two blades of servers strapped together in one logical instance. So it allows us to use Hyper-V or VMware as our hypervisor layer, so that the hardware and software is abstract from each other. We can then introduce a number of VMs. So in this example, we've got Wonderware System Platform, InTouch, that kind of stuff. But the FT server is by name a fault-tolerant machine. So if you were to open up the box of an FT server, what you're going to see in there is a sort of industry-leading Intel chipsets, x86 architecture that you'd expect to see on, on the latest commercial-grade server, commercial-grade machine. But out of the box, it's got a unique piece of software called an automated uptime layer, and what it does is it ensures that both slices of that machine are computing exactly the same task at exactly the same time in something what we call lockstep technology. So what that means is if you can suffer a failure or multiple failures on that top slice, let's say, it could be a processor or a sticker RAM or something like that, then that bottom slice is already doing exactly the same task at exactly the same time. So it just powers on through and rides through that failure without suffering any loss of downtime, which is slightly different to other sort of IT type technologies. But what sets it apart really, and why I've mentioned it today, is it's so easy to manage. So those IT technologies, whilst heavily used even in the OT industry, they do take a certain skill set to manage. And if you don't have that, or you're in remote locations, let's say, the Stratus machine is very, very easy to manage. So the reason for that is obviously it self-monitors and heals itself in some cases. It can take a whole subsection offline if needed, with the ability to dial home to the support center if needed. So if that top slice did fail, processor dies, memory, hard disk, whatever it might be, the machine is intelligent enough to dial home. It will order a replacement part, a replacement slice, and that will be shipped out next business day or received next business day for the operator to rectify. So what that would entail is the top slice would be removed by using a couple of thumb screws. It's very easy to do. The new slice being inserted, and the system will then bring itself back up to speed into full duplex mode, back into lockstep technology, lockstep mode, without suffering any degradation of service. So like I say, it continues to ride on through those failures, those hardware failures. So I did mention the IT solutions then, so this is a slide which explains it quite nicely. So on the far left we've got a standard server, so this is a standalone machine that you might get from Dell or HP or something like that. So it's obviously not designed for high availability, it's a single point of failure. So when this dies, if it's running a critical process, your processor's died, it's suffering downtime whilst it's waiting to be repaired. So typically you've an engineer would come along, install the replacement parts or bring out a new machine to get you back up and running. But in remote locations, that can be quite difficult and time-consuming to get that machine back up and running. So we'd call that 99% availability. And then if we move to the right-hand side, we've then got a clustered environment. So this is the IT type technology that I touched on earlier on. So this would use maybe the same type of server on the left, but introduce a replica of that, and then you'd link them together with a heartbeat so that both servers know what each server is doing. With this solution, you need some additional hardware, so there'd be at least 2 network devices, and then some sort of shared storage, a SAN, a storage array network, to implement the solution. You then need some sort of failover script so that the applications are cluster aware too, so when one server goes down, the other server is aware that that's happened, and it can come back up as quickly as it can. So you may need multiple copies of the application, and whilst it may come up really, really quickly, it is recovering from a failure. It isn't preventing downtime. So any computes or transactions that haven't been written to disk at the time of that failover, the chances are they're going to be corrupt or deleted or not committed to disk. So potentially you've lost some information there. And then if we move over to the right-hand side, again, to virtualization HA, that's something like VMware HA, that kind of product. And it's a similar setup to the cluster, but using or leveraging virtualization technologies to further enhance it. So you wouldn't need to make your applications cluster aware, but you still need those additional pieces of hardware, so there are at least 2 network ports, at least 2 servers, a storage array. But again, when one of the machines goes down, it's going to fail over, albeit very quickly, to the other machine. But at that time of failure, any information that isn't committed to disk, potentially you've lost it. So then if we move over to the FT server on the right-hand side, this machine is built to ride through failures. So rather than clustered solutions where they try to recover from a failure, the FT server will just power on through it. And because it is a logical single machine, you only need 1 copy of the operating system or the application for each instance, and there are no failover scripts. So it just means that obviously you don't need the expertise to manage that kind of solution. You've got peace of mind that it's just going to ride on through failures. And potentially it is a less expensive solution because you don't need obviously the IT know-how to run it tied in with the fewer applications that potentially you're going to require. So just a quick snapshot of some of the sort of simple server virtualization machines that we can offer. So we're also partnered with Advantech. So if you need a small machine with a couple of virtual machines on there, we can look at alternatives too. So centralized servers, it obviously allows us to then make use of RDS or remote desktop services. So we operate or provide Thin Manager in those type of architectures, which allow us to use thin clients instead of those PCs, and I'll come onto this a little bit later. But the USBs are locked down by default, and nothing is stored on the server, so it really protects your IP. The integration with Active Directory allows for centralized user authentication and group policy, and it allows you to, obviously other applications, things like Wonderware applications and Thin Manager are going to be able to make use of those Active Directory credentials. And it allows us to use location-based authentication, so you've got the right user in the right location with the right concept delivered to them. So that's obviously very, very secure. So if we just move on to Thin Manager, for those that aren't aware of what it is, essentially it's a content broker for in use with a RDS architecture. So it's very simple to use. It's all wizard driven, and it takes the complexity out of remote desktop services, if you like. So it was launched in 1999 by what were a set of integrators in the US called ACP. Because they were obviously from our industry, the application has been designed with the OT engineer in mind. So a very simple solution to use in our industry. So to give you a visual representation of what it does here, we've got a traditional automation network. So we've got a control room there with a couple of PCs in it, a plant floor with some more PCs in it, and then some offices. So each of these machines has a monitor and a keyboard and a mouse. And what's on those PCs is an operating system in each instance. So that's an operating system that you're going to have to patch and manage, make sure that it's got the latest security patches on there. It could be that some people have got XP, Windows 7, different instance of it. You've also got your applications, so again, it could be that you've got InTouch or System Platform or whatever it might be. Again, you might have InTouch at a certain version on one machine that differs from another, making sure that if one of those machines fails, that you've got the right version of the application installed. We've also got some antivirus living on each machine. All these machines have got moving parts, so they're susceptible to failures, dependent upon the environment that they're sitting in. I would imagine they've got fans in there, and potentially if they are in harsh environments with lots of dust, those fans are sucking it in there and impacting on the lifetime of that machine. And they've also got USB access, so that analogy that I mentioned earlier on, where somebody sees a USB stick in the car park, they get a little bit curious, they've got the ability to infect the network by plugging that in and running an executable or something. So then we can propagate that through all of those instances on that plant floor. So now we've got lots of operating systems to patch and manage, lots of applications, and if a PC fails, obviously it's a laborious task to replace those. So then if we introduce a Theme Manager solution, what we've done here is we've introduced a server room. That server room's now got two terminal servers in there, and we're going to introduce the operating systems, all the different applications, and the antivirus locally to those machines. And you can see by the graphics there, we've now replaced the thick clients, the traditional PCs, with a thin client. What we don't show there is potentially in that control room in the top left-hand corner, that might be a single operator. So if we wanted to, we could consolidate that even further and have a single thin client between those two displays, and maybe even a single keyboard and mouse, so that operator can drive two displays from a single physical interface. So we've now removed all of the operating systems, all of the applications and antivirus from those physical machines and put them onto the terminal servers in that server room. We use Theme Manager then to distribute the right application to the right user or the right device or the right location. So a very neat solution and very easy to centrally manage going forward. And like we mentioned earlier on, this is integrated with Active Directory. Now if we take a look at our SCADA zone area of the network, by introducing the thin clients with Theme Manager, I mean, obviously you can still use RDS without a Theme Manager product living on there, but I guess what you'd typically see is those thin clients that you'd use would still need some sort of lightweight operating system to broker that connection. That operating system obviously needs to live somewhere, so you've got a hard drive or a small storage device living within that thin client. So the cool thing that we get with Theme Manager is it allows us to use what we call a zero client. So there's absolutely nothing living on that device because there's no storage on there. It'll just have a processor and memory on board. Because it is a zero client, it means that there's no IP living on that device. So if you imagine that somebody wants to remove one of those thin clients and take it away from the network, as soon as they do that, it just becomes a metal brick. You know, there's nothing on there to steal. Your IP is protected. And as I mentioned earlier on, the USB ports on a thin client device are locked down by default on Theme Manager. So in that analogy where somebody takes the USB stick out of the car park, with Thin Manager by default, it's just not going to work. It's not going to do anything. So very, very secure. And if we look at some characteristics of these zero clients, you can see in that circle there, we've got a multitude of well, they look like metal bricks essentially. So they're a industrial grade thin client. Really great lifespan on them because they don't have fans or moving parts. You can put them into typical industrial environments without worrying about dust getting sucked in there and whatnot. In the middle there we've got a panel PC, so that can be a thin client too. So some people like those if you have a failure with a client and you're not sure whether it's the display that's faulty or the thin client that sits behind it. By utilising an all-in-one solution, it means that the operator's just got to swap one device to swap over without trying to fault find. So one of the great advantages of Thin Manager is it is very easy to replace a thin client. A couple of minutes, very little IT knowledge to be able to get up to speed. So I would suggest that OT personnel are very capable of doing that without having to get a PC out of stores and get it up to the right versions, the right patches, or get it imaged up right before it goes back onto the plant floor. And if you suffer a failure with Thin Manager on one of these devices, the application is running on the terminal server, so that will continue to run. You're not suffering downtime. You've lost the visibility element of that process until you very quickly get one of these clients replaced. Whereas in a thick client solution, if that PC dies, and then you're suffering downtime from the off. So Thin Manager allows us to, like I say, deliver content. So we put that on the terminal server. You can see that on the left-hand side. It doesn't really care what that type of content is. So it could be SCADA application, batching application, MES. You can overlay IP cameras, feeds, and that kind of stuff. And then you dictate where that content goes. So it might be that you've got an operator station in the SCADA zone. You can set that content for that device, or you might want it to be defined as a user, so it follows a user when they log in and out of a different machine, or you can have it set by location. So somebody walks into the SCADA zone, the production environment, they get relevant information to them for that zone. As soon as they walk away and leave that area, that information isn't available to them anymore. And whichever location they've now moved to, they will get the relevant content for that area automatically to their device. So this is an example of that, really. So in the top image there, you've got a typical sort of OT operator. He's just got access to that HMI server on that top layer, nothing else. So when he badges into the machine or logs onto that device, all it's going to do is pull through his application from that HMI server. Whereas when we look at the bottom image, we've now got a supervisor. So on that same machine, he can then put in his credentials or badge in, or whatever way he's going to use to authenticate that he's logged into that machine. He's now got the ability to access the work order server and the admin server too. So when he logs into that machine, it's going to give him additional content to that initial guy that logged in. So that could be, KPI reports, OEE data, that kind of stuff. So Thin Manager allows us to use relevant user services. So really, it's just a way of authenticating who sees what content. So you can use RFID badges if you want to, biometric methods, so fingerprint scans, that kind of stuff, and it can all be linked to an Active Directory account. So it just makes it very, very easy to manage who has the ability to see what information. Very, very secure. So in summary then, we'll go back to that past, present and future diagram that we used earlier on. So we've got this air gap system on the left-hand side. We do still hear of people operating that way, but really it's just prudent to think of the other advantages that you could get, the more flexibility by operating in a different manner. So In summary, you could stay with that isolated architecture because it will address some of the security fears that we know exist there today, or we can implement these other solutions. There's obviously pressure from IT departments or enterprise services where it's prudent to make use of different information, different reports that are available today in different areas of the facility. So by implementing these structured or everything connected architectures, it just means that we're more agile. We've got access to more reporting information. So above all, we can improve the bottom line. So that takes us to the end today. For more information, you can head over to our website or email us at info@solutionspt.com. If you've got any questions, if you want to fire those over to us, and we'll endeavour to answer those as quickly as we can. So I'd like to end by just thanking you for your time today. I hope you enjoy the rest of your day. Thank you.